Hi, welcome back. So now I'm going to solve 900 rated problems from CP31 sheet live here. So I have never seen these questions before. So this is the first time me solving those questions. So yeah, I just want this study session useful for you also and motivating so that you can also stay along. So my target is study for 3 hours and take breaks in between. So yeah, come on in and yeah, join the study session. Make it useful for you also. So the first question is deletive editing. Daisy loves playing games with words. Okay. Okay, for every word, she removes the first occurrence of the letter from the word. Okay. We have to see if we can get the final word from the initial word by playing this game for zero or more turns. Okay, so if we can get the final word from the initial word, we have to print S, else we have to print no. And let's see the number of test cases. The number of test cases is 10 power 4. And every word is of at most 30 uppercase English letters. So let's try let's talk about the question here. As we know, let's see the time. Time is 3 seconds. Okay, 3 seconds. We know for 1 second it is 2 into 10 power 8. Okay, so 3 seconds. 6 into 10 power 8 operations. So, and we have test cases 10 power 4 test cases. So, for every test case, we have 6 into 10 power 4 operations, but one test case length of string is 30 at max, right? So we can take it to n square, n cube, n power 4, whatever we need. Okay, let's take the input first. String inner, initial, and final. Initial, final. So for every letter, we'll delete the first occurrence. So this is the final one. So what does this mean? This means only final occurrences of all these letters should remain in the string, right? If at all it remains. So let's go from back and check. So if we see E, the last occurrence of E is this. And then if we see M, the last occurrence of M is this. If you see R, the last occurrence of R. If you see T, the last occurrence of T. Then these should remain. And if we see for this question, T or M, the last occurrence of M, the last occurrence of R, but this E, this is not the last occurrence of E. There is an E after this. So we can't do this. Okay. Okay. So there should we go to the last occurrence of a letter, and then the before letter's last occurrence should be before it, not after it. Then we can do this. Else we can't do this. Yeah, great. So int n equal to any dot size then okay, at max we can have 26 uppercase letters. So let's create an array of, let's create a vector, 2D vector, which stores the occurrence indexes for every letter, and we just sort them. Then what happens after we sort? Then we can see the last occurrence of this is this. It should be before it. Yeah, let's go. So for int I equal to 0, I less than n, I plus plus, we are storing vector 26, right? So store of s of I, okay, any of I minus cap a dot push back I. Okay, this will already be sorted. We don't have to sort them actually. Okay, but we want them in the descending order, right? We want them in the descending order. Let's see how we can do that. We just traverse from back. For int I equal to 0, I less than m, I plus plus. Int last index equal to minus 1 here. X equal to store of minus a dot size. Okay. So if store of fin of x minus 1 is greater than, oh no, it should be less than last index, less than the last index. We continue. Last index, if it is greater than or equal, it's not possible. C out, no, numerator. Yeah, else, if it came out of the slope, that means else. We can just pop back, right? Pop back. This one. This will become the last index. Yeah. If it comes out of this loop alive, then yes. Why is this taking so much time? Why? This should not be possible. We are good till here. We are creating this. This is also fine. This is also fine. Let's decode with one after the other. Oh, for this also we are getting this. Why? So let's decode. For D, it will be 0 and N. Last occurrence of E. Last occurrence of M. Last occurrence of R. Last occurrence of T. This should work fine. Why is it not working? C out and N. अरे यार, yeah. Why am I doing this? Okay. We have to check from the last index, na? But still, why are we getting sick term? Sick term last index of this is this. Last index of R. It is greater than this. So you have to return C out no, na? Just huh? I'm sure there is some problem with this. Because what am I doing for me to get sick term? Right. Let's run here. Yes, no, no, S, no, S. This is working. There is some problem with that, I guess. Let's check this. Okay. See, it worked. What's the problem? Acha, now it is working. Wow. Yeah. So, have you understood the approach what we did? What we did is for every alphabet, we stored all the indexes where it is being appeared. And then for the final one, what we have to do for every occurrence from the last, for suppose this is TRME, right? So for E, let's store the last index of E. And then for M, for this M, the last index of M should be less than the last index of the before element. So this is the last index of E and last index of M is this. This is less than the last index of the before element. So we are able to find. And the elements can repeat, right? So we are removing this index from the vector that we stored, because for the next occurrence of E, the last occurrence of E would be not this, the before one, right? So that's the reason I'm popping back. I'm using pop back, right? And we are updating the last index. If the last index of the present element is greater than or equal to the last index of the before element, we are just printing no and then returning. And this is also a edge case. If there is an element in the final string that is not present in the initial string, then also we can't do that. So we are printing no and then we are returning. Okay. Hope you understood this. Let's just now move to the next question. Array coloring technique. Okay. So what is this question about? You're given an array A of n integers. Initially, there is only one copy of the given array. You can do operations of two types. Choose any array and clone it. Okay. Uh, we have an array A. Okay. We can choose any array and clone it. After that, there is one more copy of the chosen array. Swap two elements from any two copies, maybe in the same copy on any positions. We can swap two elements. Okay. You need to find the minimal number of operations needed to obtain a copy where all elements are equal. Okay, okay, okay. Fine. We can what? Minimal number of operations needed. Okay. We can clone it and we can swap. So swapping elements from the same copy won't do any good, right? It just increases the number of operations. So, okay, let's see which number has the maximum number of occurrences in the array, and we clone it. After we cloning, we do all the swap operations, and then we clone it again if needed, right? Because without doing the swap operations, you can't, even if you clone, the number of operations that you need will increase. For suppose, let me tell you with an example. Okay, this is the question. So, array is like 5, 4, 5. So, the number of occurrences of 5 is 3, and we want 3 more occurrences of 5, right? Okay, let's take yeah, one more number also. And size of array is 7. So we want 4 more occurrences of 5. So what we do, we copy the array. Okay, now we have two arrays, 5, 4, 3, 5, 5, 2, 1. At any case, we want all these places to be swapped, right? So let's swap it in the beginning only. That reduces the number of operations that we need. So we swap this 4 maybe, and with this 5. Okay, and then this 3, and then we swap this 2 with a 5. This is the array that we have, and then we copy this again. Then 6 fives and 1. Because if we don't copy, then for suppose the initial array may be 8, 9, 0. Okay. So this also have 8, 9, 0. If we don't copy, what happens? If we don't copy, the array would be like 5, 5, 5, 3 occurrences of 5, and remaining all some different numbers. 9, 0, 8. These are the remaining elements, right? If we just do the copy operation twice, 5, 5, 5, 4, 1. Let's just copy only, na. If we just do the copy operation twice, see, the number of fives is 9, right? We're getting only the 9 fives, but the size of array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we want 10 fives, but we have only 9 fives. So for that, we again have to do one more copy operation. But whereas when you don't do this copy operation and just transfer all these files into this array, we have 6 files in the array, and then when we copy, we'll be getting 12 files, right? You got it? I hope you understood this question, the logic behind this. So, yeah, let's see the constraints. The constraints is the number of test cases is 10 power 4, and the line is okay. The length of the array is 10 power 5. Okay, we have n. We have to adjust the sum of n over all test cases does not exceed 10 power 5. So we can go up till n log n and big of n, or n root n times complexity. So let's think about the approach. Okay, we'll take a map and we store all the occurrences. 10 power 5. Okay, map works. We take a map and store the occurrences, and we get the maximum value of the map, maximum value of the stored values. And then after getting it, maximum value, the maximum value, with that maximum value, we need to make it equal to the we need to make it equal to the size of the array. For suppose 3 and 10. What we do? What do we do? First 3 gets copied and then 6 gets copied, right? So 3. Okay. buffer is 6. So with that, first we get 3, and then 6, and then this, and then 12. So 3, 6, 12, 3, 3 into 2, 3 into 2 into 2. It's like geometric progression. Mhm. The sum of this geometric progression should be greater than or equal to this remaining buffer. Okay. Okay, let's write the mathematical formula. It's just the geometric progression. Okay. 3 plus, okay, a plus 2a plus 4a plus 1. Sum of GP formula a into r power n minus 1 by r minus 1. 2 power n minus 1 by 2 minus 1 is 1 should be greater than or equal to x. Right? We have to find this n. 2 power n minus 1 should be greater than or equal to x by a. 2 power n should be greater than or equal to x by a plus 1. N should be greater than or equal to log base 2 x by a plus 1. Okay, and we take what? We take the seal of this. This gives the number of copy operations that we need. Okay, this n plus x is the answer. Okay, we're good to go. In n, C in n, vector n, array of size n. Let's just store the maximum value also. Answer equal to n minus maxi. Okay, and LL copy operations needed equal to seal of log base 2 of what if x by a is not there. For suppose let's take this is 7 and this is 3. 7 by 3 is, if we take normal division, 1 plus 1, 2 is 1. But we need how many copy operations? 2. 2 plus 1, 3. 3 is like 2. We need to take the seal of this again. Uh-huh. Let's do this then. X plus a maxi, right? Maxi is the a here. Maxi minus 1 by maxi plus 1. Yeah. What does x? Okay. X is n minus maxi. So n minus maxi plus maxi will be n minus 1 by maxi plus 1. Answer equal to answer plus co. 7 by 3 is 2 now already. Mm-hmm. N minus maxi. 1 point something, you'll get two copy operations. 3 plus 6. Yeah. Mhm. When you have a doubt whether you need to take this or not, let's just try it with an example. The network is so slow. Let's just do this. This needs a plan. Really? Yeah. By the way, I forgot to say you Happy New Year. Happy New Year, guys. Ah, sad. This is delivered the wrong address. Why did I get wrong address? Why did I get wrong answer? Okay. Let's just check. So, we do need that many swap operations and minus maxi. We do need these many swap operations. That is pakka. And how many number of copy operations that we need? We are not sure. X by A. Hmm. That is 3. When you need this or greater than this. 6 plus 3, 9. You can accommodate till 9. Right? You can accommodate till 9. Mm-hmm. In the worst case, it will run. The problem is with seal and all this. Okay. Let me check what the problem was with that exactly after this. The problem was with steel. Something that I took there. X by A. I don't know whether. Okay. Now the next question. Make AP. Polycarp has three positive integers A, B, and C. He can perform the following operation exactly once. Okay. Choose a positive integer m and multiply exactly one of the integers a, b, or c by m. Okay. Can Polycarp make it so that after performing the operation, the sequence of three numbers a, b, c forms an arithmetic progression? So the difference between these two numbers should be equal to the difference. We sorted, and the difference between these two should be equal to these two. Note that you cannot change the order of ABC. Oh, we cannot change the order of ABC. Come on. Formally, ding, 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 ding. Okay, we're given three numbers, and we can take any number and multiply any number and positive number, positive number, positive number. We multiply any number by m. Then it should form. Okay, we have to print whether okay. 10, 5, 30. We can even multiply the last integer also. Okay, to multiply the middle integer. Okay, first now there are three numbers a, b, c. C minus a is the difference is 2d. We want d equal to c minus a by 2. C minus a should be an even number. Okay, if it is an even number, the difference we got, and the difference a plus c minus a by 2 is the difference equal to b, right? Mm-hmm. It should be b. It is x into b. A plus c minus a by 2 should be divisible by b. That is the condition. C minus a even and a plus c minus a by 2 should be divisible by b, then s. This is for dividing percent p equal to 0. This is the condition for multiplying the middle number. When we want to multiply the first number, c minus b is the d. A, B, C. This is G. And x into A equal to B minus T. B minus T equal to x into A. So b minus d should be divisible by a. B minus D is C minus B. Should be divisible by E. 2B minus C should be divisible by A. Then S is A, B, C. When we have to multiply the last number, B minus A equal to D. B plus D equal to X into C. B plus B minus A equal to X into C. 2B minus A should be divisible by C. Then S. So these are the three conditions that we have derived. This is pure mathematical, by the way. So let's take L A B C. If C minus A percentage to equal to 0, and let's just write this in brackets for more clarity. And A plus C minus A by 2 percent equal to 0. This one, or 2 into B minus C percent A equal to 0, or 2 into percent C equal to 0. This is C out. Yes. Else. No. These are the only cases. It should pass. S, no. S, no. Uh-oh. Okay. 211. Which case is it satisfying? Mm, okay. C minus A is not greater than 0. This is a condition. This condition is not satisfying. And then the second condition, 2 into B minus C. 2B is 2 minus C is 1. And 1% by 2 equal to 0. This is also not. 2 into B minus C, 0. And 2 into B minus A should be greater than 0, Baba. Because 0, 0, 0. No, plus 2 fifth. 1, 2, 3, 4, 5. 1, 1, 2. C minus A, 2 minus 1. This is failing. 2 into B minus C. Okay. 0. 0% by any number is that. Okay, 2B minus C is 0. We can just multiply it by 0, but positive integer. If it is equal to 0, then this should also A should be equal to 0. For that, you need to multiply A by 0, but that is not a positive integer. Come on. This no is no. Mhm. This is such a simple question, but you must edge cases. Then you are lost. Let us just take a quick break. Okay. Hello guys, I'm back now. So yeah, it's been 1 hour 6 minutes from the time I started live. So 2 more hours to go. Old grasshopper. The grasshopper is located on the numeric axis at the point with coordinate 0, x0. Having nothing else to do, he starts jumping between integer points on the axis, making a jump from a point with coordinate x with the distance g to the left. Grasshopper moves to x minus d. This. The grasshopper is very fond of positive integers. So for every integer I, starting with 1, the following holds. Exactly I minutes after the start, he makes a jump with a distance of exactly I. So in the first minute, he jumps by 1, then by 2. Okay. The direction of jump is determined as follows. If the point where the grasshopper was before the jump has even coordinate, then he jumps to the left. Otherwise, he jumps to the right. Okay. 10 per 14 test cases. Okay. So sorry, 10 power 4 test cases. Why I was thinking because the time limit is 2 into 10 power 8 seconds. How can they give 10 power 14 test cases? If it is even, he moves to the left, otherwise, he jumps to the right. For example, if after 18 consecutive jumps, he will jump distance. Find exactly where the grasshopper will be after exactly n jumps. Okay. Okay. If it is odd, let's just think. I need some time. N is 10 power 14. We can't do 10 power 14 operations. We can't do brute force here. We need to simulate cleverly. Okay, first he starts at an even position or he starts at an odd position, right? If he starts at an even position, then left, okay, then right, okay, even position left, he goes to odd position and then right, again gets to even position, odd, even position, odd, odd, even, Odd means he jumps to left, na? Even he jumps to left. Or he jumps to right. Even he jumps to left. Odd became. Odd he jumps to right. Odd became. Or he jumps to right. One, two, one, two, even, or even. Even became even. Four, even. Five. Okay. To this side, to this side, to this side, to this side. Six. Odd plus odd even. Okay. 2 plus 3, 5. This 4 distance. It comes 4. 4. 4 difference. One left now, then what happens? Same, but reverse. Yeah, currently, as it has been 1 hour already, I am just unable to concentrate more. I just need a long break. Okay, I'll again start the stream in the evening. From today, let's just do streams, study with me streams in the evening only. So until then, bye bye.